Hey kids, Dr. T. More fun with trig identities coming at you now. I know these things can be rough, but it's good for your brain. Like exercise for your brain. That's what it is. Why do I learn all this stuff? Because it makes you smarter. Okay, we're going to talk today about the double angle identities. Now, the past two sets of identities, Pythagoreans, cofunctions, the reciprocals, of course, I can show you why they work on a unit circle. These identities, if I were to show you why they work, it'd take me about 15 or 20 minutes, and you'd probably want to jump out of your window by the time I was done. Now, if you're curious, I can do a video or I can go over it with you. But for the purposes of this video, I'm going to put the identities up on the screen and we're going to use them. And I know you guys have faith in me that they are, in fact, identities, that they are true. All right, so let's get started. Okay. Now look to the left of your screen, right of your screen, my left, your right. Those are the double angle identities, all right? Now there's really only three of them, but you see all the cosine of 2a's? Those all are transformed using the Pythagoreans. If you remember, this cosine squared is 1 minus the sine squared, etc. and so forth. So the middle three ones are just different variations of the same one, which is cosine squared minus sine squared. Okay, so there's really only three of them. Now you're going to be given these. You don't have to memorize them, but you do have to recognize them. So when you see 2 times an angle, you need to think of double angle identities. Just like when you see squares, sometimes you think of Pythagoreans. When you see, what was the last ones we did? We did cofunctions. When you see like x plus 90 or plus or minus whatever inside, you think cofunctions. Okay, all right, so let's get started. So we got the identities on our screen. We got a problem to the next to it. So it says, if the angle is in between 0 and 90, you guys think in first quadrant like I am? Okay, good. It says, and the sine is a half. Find the sine of 2x. Now, when you see the sine of 2x, you only have one choice. You can only use, let me make sure my pen is going on here. You can only use this one. That one's the sine of 2a. Okay? So we know we can only use the sine of the double angle, and that's going to be, first I'm going to write it, that's going to help, 2 times the sine of x times the cosine of x, okay? Now, they give us the sine of x, we know that's a half, so we can plug that in. Oops, don't want to do that. Who am I to be? Where's the eraser here? Come on. I always lose the eraser. There it is. Okay, so we're just going to go ahead and plug in the half for the sine of x because they tell us that's what it is. And if you're in the first quadrant and the sine is a half, the cosine is going to be radical 3 over 2, if you think about that. You're talking about a 30-degree angle. So that's one way you can do this. Okay, so now the final answer is going to be 2 times a half times radical 3 over 2. Well, those two cancel. 2 times a half is 1. So the answer is going to be radical 3 over 2. Okay? Now, another way we could have done this is kind of like I'm going to do the cosine of 2x. Now, if you have the cosine of 2x and they give you the sine, you have a choice among all three of the cosine of the double angles. All right, now which one should you choose? Well, they gave us the sine and they want the cosine of the double angle. So all of these have the cosine of the double angle. 1, 2, 3. But only one uses exclusively the sine, and that's this one. You see that? So that's why I'm choosing to use this one. So the cosine of 2x is going to be equal to 1 minus 2 times the sine squared of x. Okay? Now we know what the sine of x is. So it's going to be 1 minus 2 times 1/2 squared. Now, just be careful with your order of operations. Do the exponents first. This is a quarter. 1/2 times 1/2 is a quarter. So it's going to be 1 minus 2 times a quarter. 2 times a quarter is a half. So it's going to be 1 minus a half. And that's going to give us our final answer. 1 minus a half is a half. So that's the value of x. All right? Okay. You give it a shot there, and then I'll go over it with you, of course. Okay. So, if the sine is 2/3 and a is acute, find the cosine of 2a. Okay, so the cosine of 2a, well, they give us the sine again, right? So we have to use this one again. Okay? So now we don't know, we couldn't, if we had to, we couldn't find the cosine by thinking of our unit circle numbers. We'd have to go ahead and use a Pythagorean identity or something like that. But luckily we have the sine, not the cosine, so we're good to go. So the cosine of 2a is going to be equal to 1 minus 2 times the sine squared of a. And we know that the sine of a is 2/3. 1 minus 2 times 2/3 squared. Let's come on up here. 2/3 squared is 4/9, so it's going to be 1 minus 2 times 4/9, which is going to be 1 minus 2 times 4 is 8/9. So 1 minus 8/9, 9/9 minus 8/9 is going to be 1/9. Okie dokie. All right, so. Oh, wait a second, I messed up. No, I didn't. 2/3 squared is 4/9. Yeah, no, I did it good because I screwed up on my notes. All right, so let's go on to another type of problem here. Now the simplified type of problems. This is the only other type I'm going to do in this video. Now, if we want to simplify something, I look at this and I say, well, the cosine squared. Well, I could write that as 1 minus the sine squared. I could do that. I know that the cosine squared of a is 1 minus the sine squared of a. But then there's nothing else to do here. You're just making it more complicated, aren't you? You added another term. So that's going to be bad. So then I look over at this term and I see the cosine of 2a. Well, that I might be able to work with. Now, if I look at the cosine of 2a and I look at all of these, now if I want to combine them with the cosine squared, look at the cosine of 2a that has cosine squareds. This one. Okay? So that's how I make the choice that I just made. I look at what I have, what I'm looking to simplify, and if I'm looking to combine like terms, I'm looking to turn that cosine of 2a into the cosine squared of a. Okay, so I want to do that the most I can. So the cosine squared of a minus cosine of 2a can be rewritten. And instead of cosine of 2a, it's going to be minus, and it's going to be 2 cosine squared of a minus 1. Make sure you put parentheses around it. So write yourself a little note if you need to. Don't forget parentheses. And we're going to distribute the negative to both. So my next line can be the cosine squared of a minus 2 cosine squared of a minus negative 1 is going to be plus 1. Okay? Now let me combine my like terms because these both have an a in the inside. They're both squares. So now I know that this is these two combine, and it's going to be negative cosine squared of a plus 1. You think you're done? Take a look at it. Think Pythagorean. You're not done. If I put this in the other order, in other words, 1 minus cosine squared of a, now do you see why I'm not done? Because 1 minus the cosine squared is the sine squared of a. Doesn't get any simpler than that. So there you go. One term, one trig function. Good to go. All right, now give that one a shot, and I'll go over it with you. Okay, another simplification problem. You can't do anything on top. It's not a sine squared, so I don't think you can switch it for Pythagorean. The bottom is a double angle, though. You see the double angle? So I know I can switch it. That's going to be 2 times the sine of theta over sine of 2 theta is equal to, we only got one choice for this one, remember, the sine of 2 theta. It's going to be 2 times the sine of theta times the cosine of theta. Got that from right here, right? So let's go ahead and cancel our way to heaven. And we're left with 1 on the top and the cosine of theta on the bottom. Don't break your arms patting yourself on the back. We can write this a little bit more simply. We don't have to write it as a quotient. We can write it as one trig function. We can write that as the secant of theta. And then we're done. Okay? Now, that's going to conclude this one. Give that little baby right there a shot. Take your time with it. And of course, we'll go over it in class if you need us to. All right, bye.